All right, so 3.4 is really just going to be a continuation of 3.3 where we're solving these polynomials. And so if I go up here real quick and we look at this example, what we were asked to solve, but they gave us one of the roots, one of the solutions that will work, and we went ahead and did it, and we had a remainder of 0, which is great. And then from there, we were able to factor the problem. Moving forward, what we're going to have to do is they're not going to give us the value. They're not going to say, hey, this works. We're going to have to kind of come up with it on our own, and that's where this rational zeros theorem comes in. Now, rational, so we know what zeros mean. That means basically means solutions, right? Values that will satisfy the equation to make it equal 0, right? And so rational just means, that's a fancy word for meaning fractions. But even with fractions, even 3 could be considered a fraction because that's the same thing as 6 over 2. So rational zero theorem basically includes whole numbers and fractions, okay? And so some of our solutions, though, are actually going to have square roots, and so that would not be included in this theorem that we're about to look at, okay? So what this theorem does is it finds all possible rational zeros. Not all the zeros, only the rational ones, okay? And so a lot of times we say, remember your P's and Q's. And so the P is all the factors of the constant term. And so the constant term, for example, on number 1 is this -4 right there. That would be your P term. So you would list all those factors, and we'll talk about that in a second. And then the Q would be all the factors of the leading coefficient, which is the value in front of the highest power, okay, right there. And so what you do is you come up with all the possible combinations, and that's going to be your set of possible. Doesn't mean they work. Actually, most of them don't work. Typically only 1 or 2, maybe 3, it just kind of depends, may work, okay? And so let's go ahead and list it for this one right here. So this is going to be possible. Doesn't mean these are the answers. So x equals, and so what we want to do by factors, that means values that divide evenly into 4 or -4. It really doesn't matter. So numbers that can divide evenly into 4, well, obviously 1 and -1. And so instead of having to write both of those, we write plus -1 for shorthand. Okay, so we've done that before. And then what else divides into 4? Positive and -2 both divide into 4 evenly. And then what divides in, then also positive and -4. And so that's going to be the list of all the numbers that divide evenly into 4. Positive and -1, positive and -2, positive and -4. Then for our leading coefficient, it's pretty simple in this example. It's just a 1. So the only value that divides evenly into 1 would be positive and -1. And then the last step is where we list all the combinations that are possible here. So we divide all 3 of those by 1 and -1. And what happens basically, whenever you have a 1 in the denominator spot, it basically is just going to give you a repeat of your numerator up here. So the combinations would be positive and -1, positive and -2, positive and -4. So those are potential solutions to this equation right here. Most of them might not work, but maybe 1 or 2 or maybe 3 work. I'm not sure. We're not actually doing that right now. Right now we're just practicing coming up with the list of potential solutions. So these are potentially solutions that would give me a remainder of 0 if I were to do my synthetic division. Okay, so that one was fairly simple. There weren't a lot of them. Sometimes, there's only 6 here. 1, -1, 2, -2, 4, -4. So there's only 6 that I came up with here. Sometimes you'll get, 20 or maybe even more. So let's look at our next one. So once again, right now we're not solving. We're just figuring out our possible rational solutions. And once again, this isn't super difficult. It's just kind of weird. And it's also kind of strange that it works, right? and we'll apply this in just a minute. Okay, so once again, let's see. So we're going to have x equals, and then the, oops, that was a little crooked there. A little better. All right, so we're going to list all the values that divide evenly into 6, and we're going to put that in the numerator spot. So let's see. Positive and negative 1 would divide evenly into 6, so would positive and negative 2, so would positive and negative 3, and so would positive and negative 6. So all those numbers divide evenly into the constant there. And then for the leading coefficient, we look at 3. So we want to figure out what values divide evenly into 3. Well, that'd be positive and negative 1 and positive and negative 3. And then what we have to do here is look at all the combinations. So when I divide by, you're going to divide all the numerator values by 1, kind of like what we did up here. And what happens is you just get a repeat of the numerator. Because whenever you divide by 1 or negative 1 or whatever, we're going to get a repeat of what we already have up here in the top. So we're going to have positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. Okay, now I have to do the same thing, but now I need to do it with the positive negative 3 right here. So I'm going to divide by 3 and negative 3. So that ratio right there, when I divide the 1, that would give me a positive and negative 1/3. Okay, then I divide the 2 by positive and negative 3. So that'd give me plus or minus 2/3. And then when I do 3 divided by 3 and 3 divided by negative 3, or however, whatever combination you want to think of, that's going to reduce into a 1, and that's already there, so you don't need to repeat it. So we're not going to repeat that one. Same thing with the 6. 6 divided by 3 is 2, and negative 2 when you look at your different combinations. And so that's already there also, so we're not going to write it twice. So this is my set right here, okay? And so let's see, there's 2, 4, 6, 8, 10, 12. So we have 12 possible solutions to number 3. I know it's kind of weird, and we're not even solving them yet. We'll do that on the next page. But what you would do is you just start doing synthetic division and you try one of these numbers right here. You just try one. And if it works, great. If your remainder comes back and it's not 0, then you just try another one. And you just kind of go from there. Don't get frustrated. Sometimes it takes 2 or 3 or even 4 attempts until you find one, okay? So I'm going to go ahead and stop here, and I'll start the next video where we start to actually solve them. So this part was only about coming up with the possible rational zeros.